maximum number of vowels in a substring of given length. So according to the title, if it is a given length, it means basically it's gonna be a fixed sliding window problem. Yeah, because for example, we have a string of S, it's gonna be like A, B, C, and then triple I, D, E, F, and we gonna have a fixed window which is gonna be K. Yeah, because we are giving this length, it is K. What are we gonna do? We're gonna find the maximum number of vowel letters in any substring. Yeah, and this is the size of the substring is K. Yeah. So according to the example, so for example, inside ABC, how many vowels? There's nothing, but inside of this window, I, so it's gonna have 3 vowels, so it's gonna be the maximum number. Yeah. So for solving the fixed sliding window problem or the sliding window problem, basically this is just a pattern. Yeah. So we're gonna always traverse. Yeah. Normally for me, I gonna traverse from the left to the right, but from the right to left it is also okay. Yeah. So for easily solving the problem and for the normal case, definitely we're gonna slide from the left to the right. Yeah. So for example, this is our string. And now we have a fixed window. So this is the fixed window. Yeah. So if this is fixed, we're gonna have a count of how many vowels. Maybe here is 1, and then we're gonna shift to here, and then we're gonna update the counter. Maybe here is 2, and then we're gonna shift again. Yeah. And we're gonna shift again. Maybe here is 3, and here is the maximum number. Yeah. So this is the basic solution. Basically, it's gonna be a for loop. Yeah, or a while loop. It is just on time complexity. And by this for loop, basically we can control the sliding window. As this is a fixed sliding window, the coding gonna be much easier because inside we don't need to use the while tag. We just need to use if tag. If the window size is equal to k, it means yeah, we can calculate the result, and then we're gonna update the window. And for each of the time while we're updating the window, it's gonna have a fixed size. Yeah. Now let's try to solve it. So we're gonna prepare. We're gonna prepare a vowel. It's gonna be a set of string A, E, I, O, U, and then I'm gonna prepare a left pointer and counter and a result. It's gonna be 0, 0, and 0. Now I'm gonna loop through it for RC in enumerate. So this means the right pointer, L means the left pointer. So this count just means a counter. The result is our final result. Yeah. So we're gonna enumerate the S. Now we're gonna check this character C. If it is inside the vowels, basically it means it is a vowel. So we're gonna update the counter. And we're gonna use another if tag to check the window. So the window size is gonna be R minus L plus 1. If it is equal to K, basically we need to update the result. It's gonna be the maximum of result with the count. Yeah. So after updating, so here basically we don't need to use while loop because there's only one tag. There's not so many tags because this is a fixed sliding window. It's not a flexed sliding window. Yeah. So if the window size is fixed, after that normally we're gonna update the L gonna plus equal to 1. But before that we need to check this character. So if this character at the left side is inside the set, vowel set, it means the counter gonna minus equal to 1. Yeah, because we're gonna slide the window. If we are going to slide the window, we have to check at the left side. So for example, this is at the left side. Maybe this is a vowel. This is the character A. Now we're gonna slide it to here. Yeah. So before we slide, we need to check this character. If this is a vowel, we're gonna update the counter. Counter gonna minus 1, and then we're gonna update the left side of the sliding window. So here is the left side. Yeah. Finally, we just needed to return the final result. Now let me just run it to check and submit it. Yeah, as you can see, it works and it's pretty fast. Basically, this is a very basic pattern of sliding window, and it is a fixed sliding window. For such problem, the time complexity is O(n). As we didn't use any actual space, basically it is this file set. So we're gonna see that the space complexity gonna be O(1), and this pattern can be used in a lot of Leetcode problem. Maybe just more than 20 or 40 different kind of Leetcode problem. It's gonna use the technique of fixed sliding window. I think that's all about it. Thanks for watching. See you next time.